because this is actually on your math chart. So when you take any state mandated test or whatever, you'll obviously have access to that. So these first few slides, there's not going to be much for you to write down. You're really just going to have to kind of follow along with me. I am recording. Y'all didn't have to remind me today. But I will post this in the interactive notebook here shortly. Abby, I don't know why it's not letting you in. It's just, it's spinning and spinning. There you go. Now it's working. All right. So in order to find the equation from a graph, the first thing you're going to need is the slope. And if you notice, all of the slopes are actually different on these equations. And we know this one is different as well. So what we're going to do is just find our slope and then use that to help us. So I'm going to pick 2 points, which would be this one and this one. And the only reason I'm picking those two is because they intersect on the grid, of course. So my rise here is 3, and my run is 1, 2, 3, 4, 5. So my rise is 3, my run is 5. This line is decreasing from left to right, so that makes it a negative slope. So if you look at our equations, only one of these has a negative and 3/5. So that means this first one is going to be the one that matches those equations, or that graph. Be careful with the, if you notice there's one here that says 3/5, that's not negative, so you've got to be careful with that. Okay? So the next, we have a vertical line. This vertical line passes through which axis? The x-axis, right? The x-axis, good. And it actually passes at 2, which is why it's x equals 2. So then we know this one would be the one that matches that graph. Anytime you have just a straight vertical or horizontal, remember it's going to either be x equals or y equals, depending on which axis it passes through. And in this case, it passes through the x. So we've used this one, we've used this one. Let's move to the next one. So now we have a 50-50 chance. I'm going to do the same process. I'm going to try to see which of these slopes actually works. This point right here and this point right here. We have a rise of 1, 2, 3 and a run of 1, 2, 3, 4, 5. So it would be 3 over 5. It is increasing, so it would be 3/5. You know, another way we can check is actually by using the point. Whoops. In this case, the point that I can grab from that equation is 5, 1. So if I go to graph 5, 1, I go over 5, up 1. That point is there. So that's another way you can check. So not only does the slope match, the point also matches. Okay? So that means this one would be the one for that one. By elimination, this one is going to be the one that works for this graph. But what we can do is check that coordinate. The coordinate would be -2, -3. So I go -2, -3, which would bring me here. And it matches, so it works. Also, our slope is 3. So I would do a rise of 3, 1, 2, 3. Wait, 1, 2, 3, and a run of 1. 1, 2, 3, and a run of 1. So it works. I know I went through those really fast, but that's nothing new to you, really. It's just using it in a different context, right? All right, this next one, though, I do want you to write down, because this is a good real-life example, nice and short and sweet. So go ahead and write that down, please. All right, so we are still writing the equation. Let me switch colors. That one's not going to work very well. And y, Try that again. Y minus y1 equals m times x minus x1. In order to write this, we need a slope and we need a point. And that point, we need an x and a y value, right? So, first of all, looking at our data here, it says a train travels at a rate of 70 miles per hour. 2 hours after leaving the station, it was 210 miles from its original location. So, in this case, we need a slope. Remember, our slope is our rate of change. Remember, our slope is a unit rate and so on. So which value would represent our slope?
70.
70. Good. And of course, it's 70 miles per hour. And remember, when we have slope, it's change in y over change in x. So that means the miles is the y and the hours is the x. So I can use that to help me find my point. Which values would represent our point? What would be the x? 2. And the y? 210. Good. So when I go to write this, I would have y minus 210 equals 70 times x minus 2. So then this equation would represent that situation. Questions? All right. Next, here you just have to write the 2 points because that's the only thing you would truly need. All right. So we're going to go ahead and write this equation in slope, point slope form. Whoops. I was saying one thing and writing another. So again, we need a slope and a point. Now they're telling us which point to use. We're going to use -2, 3. But we have to find our slope. So I'm going to set up a little table here. So I would have -2, 3, and 1, -3. So I'm going to find my slope here by doing my change in y, which happens to be a -6. Change in x would be what? +3. So when I write my slope, I have -6 over 3 or -2. Now I have everything I need. I can write my equation. Y minus 3 equals -2 times x plus 2. So there's our equation. I know I went super